We're at the blockchain meetup on March 8th, 2016 in beautiful Scottsdale, Arizona. And I am Dr. Bryan Gmyrek, and I'm going to give a talk titled Hands-on with Ethereum, How to Use the Mixed IDE to Develop a DApp. Let me see. Oh, come on in. We're just getting started, so you're good.
Sorry.
No, you're fine. We're happy to have you. All right. All right, so I'll go through a little introduction since I always forget to do that. I put together a slide this time. I've been a Bitcoin enthusiast for a couple years and done a couple hackathons. I've been a full-time software developer since 2007. Prior to that, I got a bunch of degrees in physics, and I've been developing web-based software funded profit since 1987. Let me see. All right, so I wrote this kind of just for fun, but kind of because I mean it. And it's basically just an open apology to the Ethereum developers that one of the things that I continue to be impressed with is how much work people are clearly putting into the tools and everything. And what I kind of do is I'm obviously sort of an overeducated non-Ethereum core developer, right? And so I just want to try to make these tools do something. And so, you know, I'm doing sort of the horrible user thing of being like, why doesn't this work? Or this is dumb, you know? But really, it's all pretty cool, actually. Once it's one of those things where once I end up checking it out, it actually works pretty well. So anyway, I hope maybe if any of them see this, it'll maybe be helpful to see some of the pain points. I have a little, let me see, there's a video here, which it is nice to see the overview of what sort of the sales material is for Ethereum.
How will the internet work in the future? It will use Ethereum. Ethereum is a planetary scale computer powered by blockchain technology. Applications built on Ethereum run exactly as programmed, without any possibility of downtime, censorship, or third-party interference. Ethereum is the secure backbone for everything from e-commerce to the Internet of Things, enabling transparent governance for communities and businesses while keeping user communication secure. Mix, the Ethereum IDE, makes it easy to develop, debug, and deploy your applications, while building UIs is done using your existing web development skills, tools, and favorite frameworks. Ethereum handles user authentication and secure payments for you, as well as messaging and even decentralized storage. And there's no need to sign up or pay for service to host your applications, as Ethereum is the world's first zero infrastructure platform, allowing your users to regain control over the management of their own funds and personal data. Join the many already developing on Ethereum.
Okay, so if Ethereum were like a publicly traded company, right, they'd have to have a disclaimer that this contains forward-looking statements and all that stuff, right? Because, like, really, and like I said, I love it, but it's, you know, some of the stuff that they say in there isn't totally true yet, and things like that. Maybe by mixing in other services like IPFS and different things, you can get closer to this, like, sort of ideal. But, I mean, that's sort of the overview that includes some of what the functionality is now and what some of the goals are, I guess, to be fair. And probably they'll get there. I just want to put this slide to sort of remind myself to mention the video and slides for the last presentation are up there. It's really, really long, but you can always skip around, and had a lot of info of me just trying to figure out how to use some various things with Ethereum. And I went into more detail in that one on Solidity and smart contracts and mining and things like that, and some installation issues and all that. So this slide, I want to cover sort of some of the key concepts and underlying technologies. So I'm going to sort of assume that everybody here knows what some of these things mean, like peer-to-peer and cryptography, cryptocurrency, blockchain, mining, you know, because those are a lot of things that went into the sort of, if Ethereum is standing on the shoulders of giants, those are some of the giants. And smart contracts, so we'll talk about these in a couple of the following slides. These are not unique to Ethereum, but they're one of the big, you know, having more advanced smart contracts is one of the big selling points to technical people. And then the Ethereum virtual machine I'll touch on a little bit, and then what is a DApp. So smart contract, I just grabbed some info. Smart contracts, cryptographic boxes that contain value and only unlock if certain conditions are met, can also be built on top of the platform with vastly more power than that offered by Bitcoin scripting because of the added powers of Turing completeness, value awareness, blockchain awareness, and state. So one of the things that they've started adjusting a little bit in the marketing materials is the idea of Turing completeness versus what they're now calling quasi-Turing completeness. So if you're not like a computer scientist or developer or whatever, sort of a Turing complete programming language is a programming language that you can do anything in. So I mean, you can program any program that could be programmed, to just do various things. And they've sort of revised their marketing to be quasi-Turing complete because technically there are the gas limits and everything that exist make it so it does have stopping conditions beyond just arbitrary. There are non-arbitrary stopping conditions, I guess. But it's a limit, whatever. It still is pretty. The idea with gas is it costs money to run your contract. And then the gas limit will be you can put some limit on how much, the idea is you design your contract to like use only up to a certain amount of gas. But then there are gas limits even beyond that, so if your contract goes wild, it won't use up all your ether or something, and some miner will end up with like a bunch of ether. So that's sort of the
So to your knowledge, the limit to Turing completeness is only due to the gas limit. It's not due to something inherent in language.
I think that's the case. So it was like you basically say Turing complete unless you're talking to people that are more like they're like, well, wait a minute, and I didn't even know, So yeah, it's basically Turing complete. I think you just keep using that terminology unless the person is like a developer. And I just have some links. I always feel like I'm really late to the party when I see stuff written by Nick Szabo because here's his article on smart contracts from 1997. And basically he has actually I love the example he used in here. I don't know if this is readable, but I just threw it in here. This is from his webpage. He basically says, canonical real-life example, which we might consider to be the primitive ancestor of smart contracts, is the humble vending machine. Within a limited amount of potential loss, the machine takes in coins and via a simple mechanism which makes freshman computer science problem in design with finite automata dispense change in product according to the displayed price. The vending machine is a contract with bearer. Anybody with coins can participate in exchange with the vendor. The lockbox and other security mechanisms protect the stored coins and contents from attackers, sufficiently to allow profitable deployment of vending machines at a wide variety of areas. Like, holy cow. I go to great, this is like right up at the top of this page, and I think it sums up what, especially in Ethereum, and even if you start watching some of the DevCon 1 videos, everything, the stuff they talk about, getting into more smart contracts that people will start probably actually using more or already using. A lot of it boils down to that idea, like, can you make a vending machine type piece of code, something like that. So, and the Ethereum virtual machine, I'm just going to read this because the Ethereum virtual machine is the primary innovation of the Ethereum project. This is a virtual machine designed to be run by all participants in a peer-to-peer network. It can read and write to a blockchain, both executable code and data. Verify digital signatures and is able to run code in a quasi-Turing complete manner. It will only execute code when it receives a message verified by a digital signature, and the information stored in the blockchain tells it is appropriate to do so. So basically, my summary was the EVM is the thing that runs your smart contracts. Like that was, the other thing is a quote from this DApps for beginners.wordpress.com tutorial, which was actually a pretty cool looking tutorial. I'm not sure who wrote it because they didn't make it that obvious. But anyway, I thought that was a good summary. And so a DApp is like it's decentralized app, right? So that's what it's short for. But what does that mean? This is another quote from that page. Ethereum enables the decentralized web, referred to as Web 3. A DApp consists of two parts: a front end written in HTML, typically, and a back end, which is sort of typically like the blockchain. But so my little summary at the bottom is typically a DApp is an app which runs in the user's browser. It could also be a native app, but typically they seem to be written in JavaScript and everything now, in a way which is nearly identical to how most modern web apps work. The difference being that select data can be read from and written to the blockchain, and select code can run in the blockchain. Because I started doing more research around give this talk and stuff, and trying to watch videos on how different people approach the app development, and and all that stuff. And that's what it seems to be one of the key things to think about, is that it's just like how, let's say you're running a normal web app. You know, you're running this application and like a lot's happening. I mean, there's like stuff moving around the page and animations and you're clicking stuff and all this stuff's happening. But once in a while, something's written to the database. You might not know it, but it does, and you're trusting, you know, that that's happening. Like in Facebook, you had a new friend on some database somewhere that's stored that you did that. That's the sort of stuff that you think about, you know, if it's permanent data or something that you want to be able to access later, like to figure out who your friends are or whatever. That's the sort of everything else, all this, it's not like you're running the app and the whole app is running inside the Ethereum blockchain. It's mostly just running JavaScript just like everything else. It's those operations that need to be secured by the blockchain or stored or something. Okay, so let me see. I just have a little summary about installing Mix IDE. I think I talked about this more in January as well. I think things might have gotten better over the last couple months. I didn't go and try to redo it all because I was like, I didn't want to end up in the state of not having the stuff working as I was trying to finish this talk. But I know there's been a lot of active development, so maybe it's gotten better. The big thing for me on the Mac was there's this page, github.com, somewhere on GitHub. And, you know, this page, anytime you see like Here Be Dragons talking about installing stuff, you know, it's a little scary. There are like different workarounds you do to get Qt working and everything. It worked for me. Once I followed the instructions there and then followed the standard ways to deploy it, I was able to get it installed, get like the Mix IDE and the ALET 0 and stuff.
Can you briefly cover, does it work on Windows okay, or is there primary target Linux?
Right. So on Linux, I found it's like, because I also have a Ubuntu 14.04 box, and that everything installed more easily in there. It's just like apt-get install, it's just like works.
It's probably the target.
So that's probably the target. My only issue was I had it all installed, but then when I tried to open the Mix GUI, it crashed, or it was like all just black. Like something was wrong that it probably could have fixed in not too much time. I sort of gave up because I also wanted to get it to work on the Mac. Yeah, it was probably a Qt issue. So, you know, whatever. I think it'd probably be easier to do. Getting it working on the Mac was, I'll show you a screenshot of this: preparing your Mac for installation of ALET 0, ALET 1, and Mix. So there's 3 GUIs that you can install, the Mix IDE being one of them. One of the big problems with this, it says like, warning, this may take up to 4 hours. It took 4 hours. So it's like, yeah.
That is no joke.
It really did take 4 hours. Like Qt, it was a Qt thing. Yeah, and it was like, it took 4 hours. I think I compiled it. I don't know what happened. It compiled it from source or something probably. I don't know. So, but it worked. It was like, you know, beyond it taking 4 hours, I just like pasted, you know, I just pasted the commands from this page and it worked, you know. The other thing I mentioned in here, and I think, you know, obviously there's a lot going on. So the people there's a lot of active development, and it looks like this. I mean, when you start clicking around, like when I first installed it, at least a few months ago on Ubuntu, I was like, oh, okay, it's CPP Ethereum. That's what I was calling it to myself because that's what it seemed to be called, and that's what the command line thing. No, and it's like now they link you to Web3 umbrella. So if you go to CPP Ethereum link on GitHub, it says this is now defunct, and it's a thing called Web3 umbrella, and it's an umbrella project that it includes it. And then if you start clicking stuff on that, you end up on a page called Turbo Ethereum as like a hint towards like Turbo C++, I guess. Anyway, it's a mess. And as far as I could tell, whatever, if you're on GitHub, it seems like they've at least updated the pointers and links. You'll get to the right place eventually, and I have some links in here as well. But yeah, so that was kind of fun. On one of this Gavin Bjork, he has this Git book, and it's pretty handy. He has this info on here, and I just like sort of screenshotted it because he's got ALET 1, and I got confused. I downloaded it, I got these GUIs. I was really just looking for the Mix IDE at the time, and I was like, what is this other stuff that I have now in my applications folder, you know? And so there's one is ALET 1, the mainline Ethereum desktop miner. It connects and syncs to the Ethereum network and lets you mine and send transactions. It'll also let you do pool mining. I haven't used it because if I'm mining, I'm doing it on the Linux box and I'm using GPUs and I don't use a GUI or whatever. So, but presumably it works. I don't know how much you'd make mining with a CPU, but for fun anyway, or just to make a little bit, could be good. ALET 0 is the power user Ethereum client. It connects and syncs to the Ethereum network and lets you mine, make transactions, run DApps, and inspect the blockchain. This plugin set allow arbitrary extension. So I didn't even really end up using this much. I did open it and stuff. Here it is. It's very like developer focused. So I mean, the first thing you end up finding out is like it was very wonky. Like if I try to resize it, so I should. That's like I said, it's wonky in the sense of as a as a sort of a crying user saying, why do I have to like I had to just like close some things and reopen them to get them to size right or whatever. But it lets you do all this stuff. So if you're really developing like apps, DApps, and everything. All right. So yeah. Anyway, there's a book here, Gav of York. It's the same Gav's Git book, and he just talks about Mix a little bit there. And then it's a little bit out of sequence maybe, but I brought it up partly because as I was doing more research, it's like Mist keeps coming up because it's sort of like I said, it's the promised sort of like what every user will have on their lap. So every it'd be the GUI that every serious Ethereum user has on their Mac or their Windows machine or whatever when it's available everywhere, and it'll be where they can do stuff that's like with their wallet. And then it'll be also like a source where they can find and use DApps and things like that. Oh, here we go. I have a screenshot of it, so I don't have to. So yeah, here we go. This is the screenshot, and you can see you have an account. So we actually, if you watch the talk from January, I used. It looks just like this, but it's like a Node.js version running in a browser. The difference with this one being it looks just like a normal sort of Mac OS X app. I think it's internally probably using whatever Node WebKit stuff that you can create an app out of, but to the end user, it just looks like any other desktop app. So,
Is that a DApp itself?
yes,
Wallet and
yes.
DApp?
So that's sort of like that's a good point. That's sort of like a reference app, which also proves that okay, maybe it is using JavaScript, but it looks you can make dApps that are look like desktop apps too. Yeah, right. You do all that stuff. So yeah, it's a DApp, and I guess it's sort of like if anybody, especially anybody who's serious about. Because it does a lot of stuff. So if you're serious about writing a DApp, deconstructing that thing is probably a good idea, because there's a lot of talk out there, but it's an example of a pretty good version. I just had some links to some videos that I found were good. I'll just look at the titles right now, though, to give you an idea of what people were talking about at DevCon 1. Fabian talked about building DApp, what are dApps in my Meteor? So clearly he's using the Meteor web development framework as the sort of JavaScript and HTML part of the app in MongoDB. So I mean, you can, that's the difference. You can also have a database that's not in the blockchain. So it's sort of like you have your front end stuff, your normal database that's maybe MongoDB and something like Meteor, and then you have like your thing. It's almost like almost like a PayPal API or something, right? You're not going to call it all the time. You're going to call it when it involves money or it involves some piece of data people want security. Some more resources, like I said, as I dug around, I figured I'd drop all the things that I found useful. So this one talks about Web3 more specifically. So I sort of gloss over some of this, but there are docs out there that go into like what is Web3 in more detail, and I'll get to sort of more practical examples soon, but. And then so people get into, now this is already so new, but people are already writing like frameworks. So, which my take on the framework thing is probably best to mess with creating one, using the Mix IDE. I mean, it's already an IDE, it's already helping you out before you go full framework, because you never go full framework. No, but it actually, some of the marketing, at least for it, looked pretty cool. So like I said, I don't recommend starting out with this, but if you've got serious, like you've got a startup going or something, you look into the framework and they're already doing things that you're just gonna have to implement anyway, it's maybe worth checking out.
Yeah, but the framework is like a hammer, right? The world looks like a nail.
Right, pretty much, yeah. The things that, so I guess you could at least maybe get some good ideas. Like, so they talk about how you can do test-driven development with contracts using JavaScript. So there's probably stuff that you could do on your own, but maybe you could get some good ideas from the framework. So if you were getting really serious, I'd say it's probably at least worth stealing the ideas that these guys have. If you don't want to use the framework, fine. But kind of like getting an idea of what's possible by just messing with it, and then maybe being like, oh, that's a good idea. We can use. Looks like they have tie-ins IPFS, which you can do on your own as well. But maybe seeing their example would be helpful. So anyway, that's so what I figured I'd do, and I didn't want to live code it because I have too many. It's like this way we don't have to worry about stuff going wrong. But it is a pretty, I paused it a couple times, but basically I'm just saying, okay, here's this Gab of York.getbooks.io thing, and he has a tutorial in there on how to use Mix, and I'm just going to go through it. So, talks about the project editor, which you can use to manage creation of your app. Let me just fast forward a little bit. All right, so here we go. So like you're creating a new project. You have to give it a title. So this is obviously the step I skipped was open Mix. So now you've got Mix in your applications folder. Open it. When you do open it, it gives you. It's actually kind of nice. It gives you a default app so that people know where the contract stuff should go. I figured I'd follow the tutorial more, and I'll remove the default stuff it throws in and copy and paste his examples. But let me see. So to go through a little quicker, here we go. There we go. So I just copy pasted that, and I'll show a little bit of. I'm going to clean it up a little bit. One thing you can see is it's showing some useful info, like the max execution cost here. So it kind of gives you an idea, because based on the types that you use and everything, that this function could cost you that much gas if someone used like the maximum amount of storage and everything.
And that's dynamically updated depending on the code you have?
Yeah. So if you were to add like another so you'll see there how it highlights the that red, the ratings key equals value.
Yep.
That what's happening in there is this is to step back a second, because this kind of went in quickly. This is the Solidity smart contract language, and so it's a high level language that especially for something like smart contracts, where you're thinking you're not going to be writing in like a pretty language like this. So it's pretty cool. It ends up compiling down to these Ethereum virtual machine code, and but so when you do stuff in here like save stuff to in certain ways, that's where you're writing to the blockchain. So you're saving data to the blockchain. That's always going to be more expensive than pretty much anything else, that you're going to do in here. Well, I don't know about anything else, but it's more expensive than just like reading, for example, or something like that. I'm just showing some of the stuff here. How if you type things wrong, it'll let you know. So that's kind of cool. It really is. Sure, it could have more features, but it's pretty cool that it tells you when your syntax is getting weird and everything. Also, in the last talk, I showed some more using it. You may want to develop your Solidity, your contracts in Solidity in some of the other tools, because there are tools that are more focused on just developing the contract that I went over a little bit more in January. But it's certainly handy to sort of have it all integrated here. So let's see. I don't know what I was trying to show here. Just looking through. Let's fast forward a little bit. I'm just going to grab the HTML first, just to show. Obviously, this example, you can see over here that there is a tab for your JavaScript, so you can keep your JavaScript separate, as you should when you have like a bigger project. But for the example one, they just have it all lumped in together, which is fine. But just to sort of underscore the point, I figured I would just copy in the HTML first, and then show where you're going to put some JavaScript if you just want to do a quick test or whatever. Let's see. Oh, okay, and I showed how this is just how, okay, the HTML is there. Of course, this stuff isn't hooked up to anything, but you can at least, you can get your HTML set up before you worry about all your JavaScript. So let's see. Oh, so there we go. So let's paste that in. So this would be, let's just like pause for a second and get an idea of what this stuff's doing. I mean, it's pretty simple. If you're doing with JavaScript, obviously it's getting the whatever's in the query field here, the get element by ID query's value. So contracts, this is one of those special things that if you read all the docs on Web3 and everything, this is one of the contracts is a variable or object, I guess, that is exposed, to your code when you use the Web3 framework and everything.
So it's like a super global.
Yeah, right, exactly. So it's like a super global.
Antiquity.
Right. So yeah, it's a super global, and what it's going to do is it'll interface, and I'm not even sure if I'm getting all my terminology right, but it's like it's gonna the idea with the Web3 JavaScript thing is it's your API. It's weird because it's an API, but it's your blockchain might be running on your own computer. So you're running a version of the blockchain and everything, and the Web3 JavaScript thing uses RPC to communicate with your Geth client, and so it's your API it's how you can use JavaScript easily to interact with the blockchain.
Can you pause it?
Yep.
I just wanna ask
Yep.
a question.
Yeah. Looking at here. All right, so basically I'm just gonna, I was actually just checking if it would give me any syntax or info on the JavaScript. It really didn't, but whatever. I don't even know if I generate proper syntax errors. Let's see. Anyway, you've got your JavaScript there. If you know JavaScript, you can edit it. You can copy and paste it from somewhere else if you have a favorite editor or something. But I'm just, so this is like not that big a deal, right? I mean, because you're looking at it right now and you're going, okay, it's JavaScript, it's HTML. Yes, the Solidity thing is maybe the nice part that there's an integrated Solidity thing here. But if you watch my talk from January, you can see that there are other ways that even had more features to do Solidity contract development. So like, why would you use this? Right? And I started thinking like, what's the point? I mean, it's nice, but I feel like I could do some of this stuff in other ways. So this is as you start to get a tiny bit further in the tutorial, and you see why it's useful. So scenarios can be used to test and debug contracts. Scenario is effectively a local blockchain where blocks can be mined without proof of work. Otherwise, testing would be quite slow, obviously. So this is, to me, was the killer feature right out of the gate. Besides is that you don't have to try to figure. You're like, yes, I know you can always set up test nets and you set up your private test nets and all that stuff, but like this is just this GUI that comes up and it's done that for you. So that was pretty cool, and we'll show some of that.
So you really don't have to spend the Ether and all that to actually test this.
No, and of course, the real test will be when you upload it. And you'll see it's pretty cool. So I'll try not to give too much away, but it's pretty cool in terms of letting you. So you can do things, and you can see with the stuff they're talking about, like modifying initial Ether balance of an account. I'm going to skip a little bit because
Sort of like your own private test net.
Yeah, right. It's your own private test net that's just set up. And here we go. So here's the. I'll start from here. So if you notice, there's this little bug icon right there. That's the one you want to click to see these features that you're probably really going to want for developing your DApp. And so this is pretty cool. You've got an add transaction button, rebuild scenario, add block, new account. You've got. I was just kind of going through and clicking some things. So you can create accounts and give them arbitrary numbers of Ether, and they let you, use all the different things. I actually had a problem. Yeah, it was cool. This part I was having issues with, and you'll see I'll fast forward through some of this stuff. I was having issues with actually saving new accounts using the new account dialog. Again, this is the version probably from the end of January, so it may have been fixed by now. But I found a workaround for at least my testing, which was there's a way to edit the starting parameters, which you're basically editing the Genesis blocks starting. So, since it's your blockchain, you can create some accounts and just have a bunch of Ether in them in the beginning. In your Genesis block, you can pre-mine.
Can you run other clients that are also connected to this test net and sort of simulate distributed computing? Or?
That's a good question. I don't know. I do know I started to try to get into actually running the Ethereum test net itself, because I had been just running the real one because I had been mining and stuff. But I started getting into that, but I didn't. When you start looking at the docs of that, they talk about how to set up your own private test network and stuff. So I think you can. I didn't.
Someone is talking.
So that way you could share it with a team or something like that, I'm sure. So here we go. I'm trying to follow the demo. Basically what's going on here is if people are watching this video, I guess they can pause. But basically, they're just giving me some advice on how to start. So I was like, I didn't exactly follow it because I pathologically can't follow directions. But so I started doing some various stuff here. And you just see I'm just sort of playing around, but I'm trying to take over a little bit. So it's nice that they put the test data in there, but it also makes it so you start editing it and you're not starting from zero. So you're like, oh, okay, what can I change? What can I not change? So I wanted to try to sort of create your typical, a couple users. I made Alice and Bob. You'll see, so here's what I'm trying to do. I'm going to try and follow the direction where it says, let's get some Ether sent to Bob. Create another account named Bob. with 0 Ether balance. Create a new transaction in the scenario pane. Click Add Transaction and send 300 Ether Bob. So I tried to follow those directions. So I was like, oh, I shouldn't have added Bob in the Genesis block. So I undid that, and I was like, okay. Bob's now should be in the Genesis block. Let me go and try and add it. So I did the new account, try and add Bob and give him 0. So Way is the fundamental unit of Ethereum in the same way that Satoshi is. Yeah. So, but here's the thing: when I click OK, nothing happens. So, like I said, I'm sure this is a temporary bug. I was like, well, I used Bob earlier. Maybe it Ghost saved it, and now it can't write it. So I tried Bob 2. That didn't work. I think I ended up pausing it at some point to try to see if I can work around this bug or figure out what I'm doing wrong. I ended up deciding, okay, so obviously one thing we found out, yes, these are still in development, and it maybe if I had tried to install the most recent version, this would have gone away. But what I figured was, okay, instead of going that far and me breaking my whole environment, I'll just give up on that, and I'll, let me see. Eventually, I end up editing Genesis block and just creating a Bob user. So it's nice to be able to edit your Genesis block. I wish I could do that with Bitcoin, but but only me. So here we go. Instead of using add new user, I just created Bob and gave him 0. Everybody else got some Ether. I gave Bob 0. So at least for the tutorial, it achieved the same sort of goal.
Looks like whoever you create, you're basically getting their private keys for free, and that's
Right.
why you get to test with them.
Right. Yeah.
So they're not necessarily being included in the block. It's just I'm creating these private keys, and at this point in time,
They have
They
that
have
much
some.
money or something. Sure.
Right.
Yeah, so let me see, altering and reusing scenarios. So it talks a little bit more about scenarios, and so now I'm going to try to do is actually do now that I have the Bob account in this roundabout way, you'll notice this is something interesting here. So user 1 was just the first default user that they put in here, and that user has like a 1 mega Ether or whatever it is. And then you'll notice here though, it says like contract, and there's that rating contract is in there.
that's cool.
So yeah, the one that was created over here called rating, it's in there. So that was nice. I didn't have to go and type it or whatever. And then I said, okay, well, what they said was I should just send it to Bob instead of trying to transact with a contract or whatever. And so I said, okay, I'm going to give Bob, I'm going to follow the example and try and give Bob 300 Ether just to whatever. And then go here and say, okay. And then you'll notice over in this little window here, pending transaction shows up, which is kind of cool. So this is where, it starts to impress me when it just, a lot of this stuff that I never thought about being able to have a nice GUI to mess with, just kind of works like that. So now I can say, okay, and it says whenever you see a little arrow, you have to click it. And they talk about this in the tutorial, but like I said, I can't follow directions, so I started messing with it. At this point, you can click, then it says debug transaction. I was like, okay, before I commit this, get this into a block and everything, and play with this and see what it does. So it does bring up this this debug window, and it just ended up, I think because it's a simple transaction, there's not much to it. So I think it's where, right, I think if this were a contract, the call stack is just that's the address it's going to. I don't think, so there's it's, there's no logic really to it, so
There's
it,
no pipeline that tells it where to find the additional assets.
Right. So I'll show an example later of a contract and stuff. But anyway, it's a little boring for that. But so let's see. So I'm just messing with some of the menus. They have a bunch of different menus. Okay, here we go. They talked about display calls. A contract is a function invocation with a K. This is not a transaction as a contract call cannot change the state. A contract call is not part of the blockchain, but for practical and UX design reasons, it is convenient to display calls at the same functional level as a transaction. The JS icon will warn you that this is not a transaction, but a call. To show hide call, click on the menu scenario display calls. So this is one of those things where the words go through my brain and I go, this sounds important, but I have no idea what they're talking
I'm
about.
glad you didn't get me.
Right, I didn't get it. So what I did what they said, I was like, okay, it's part of the tutorial. There must be a reason that it's in here. And so I did what they said. I went to scenario and I selected display calls, and I figured I'll find out what that means, eventually. So here we go. Scenario display calls. For a while, I don't end up realizing what it means, but then you'll see at some point in this tutorial, you end up seeing what they're talking about. So then they talk about the state viewer. This panel is located below the blockchain panel in the scenario view. We've actually been looking at it I guess. Basically, the state viewer, I got a little confused here because I was expecting to see this stuff here. See these little icons? I wasn't seeing all those icons. So I'm looking here and all I see are these. So I said I must be missing something. And so I started going crazy and trying to like click everything. Like basically what it ended up being was we've been looking at the state viewer, and what it ended up being is there's just a, right above these icons, there's a little there's a little triangle. Like I said, whenever you see a triangle, you should click it. And when you click the triangle, you get these extra buttons. So I don't know why they wouldn't just expand those by default, whatever. That's a little hint if anybody's watching this from the Ethereum team. That would be a great thing. Just show those by default because it's for developers, so why not? Anyway, so we already were kind of messing with the state viewer to see what's going on. So let's just see what a little bit more. Anyway, that was what we were looking at. So we can see the state of the blockchain and that sort of thing. The Transaction Explorer is, again, it's related to what we're talking about, and it allows you to see the different things that are going on in a transaction. Let me see, get through some of this some more. Okay, so what I did to get to here was, at this point I said, okay, I don't know where I clicked it, but I said, there, like we saw before, there's a pending transaction. So I finally got to the part of the tutorial where they said, okay, click, mine a new block or whatever. And so I clicked mine a new block, and sure enough, it shows you a new block here, and you can expand the block info and see that this transaction happened in the block. So that's nice. I think, let me see, what else did I do? Oh, okay. There's a way to sort of copy the JavaScript version of the transaction info, which is handy at least for like debugging. So I just there's a little copy and paste button there. I clicked it, and I get this info. So I'm guessing if you're, for debugging purposes and whatever, seeing what's going on could be handy. I don't know.
Is it internally kept like that, or is it broken down into binary like Bitcoin does?
I think it's probably broken down further. I don't know exactly, to how, but yeah, I think it probably is. I clicked debug transaction again to see if it were any different. It's pretty basically the same. There wasn't much to do. Like, it's a simple transaction, so not much happens. We'll get to the contract soon, and you'll actually see that. Right, so JavaScript console. So Mix exposes the following objects in the global window context. I touched on this earlier with the contracts and the Web3. So the Web3 global window context object is the Ethereum JavaScript API that lets you interface with your local, I think you can actually set up URLs and stuff as well. So I don't think you're restricted to having it be, So I think it's the same thing, just, local, it's either localhost, some port, or it's some remote host and some port. Contracts is a collection of contract objects. The key to the collection is the contract name. A value is an object with the following properties: contract object, instance, address, interface, the contract ABI. So that's what I was talking about. The part of your Solidity contract that you end up having to store an IPFS or pastebin or something, it was called ABI. I don't remember what those stand for, but it's the interface definition for the contract. Because when it's stored in the blockchain, it's all compressed and just, whatever. People wouldn't just be able to guess, I guess, how to call
like
it.
an XML schema that we have.
Right. It's like, otherwise it just looks like a bunch of hex, I guess. I don't know. I don't know exactly how it looks internally, but yeah, you definitely need to, and that's definitely a little bit of it's one of those things where like, well, wait a minute, I guess that's why they're working on that swarm stuff, right? If they can have more of a decentralized storage thing linked up somehow with Ethereum, they'll be able to fulfill that promise of it really not having to worry about putting stuff somewhere else. Let's see. I was just going through this stuff. So they talked about using JavaScript console to add transactions and local calls. And it basically, like, if you're familiar with the JavaScript console, they're just saying the same thing. For debugging purposes, you can just dump JavaScript in there that's valid JavaScript and run it from there. So that's nice. The one little bug that I noticed, I don't know if it's a bug or what, but the one little interface wonkiness was that when the panel's over here, you see the black. You're seeing through it, right?
QT fail.
Yeah, it's QT fail. So when I click the little bug and this moves over here, I can see what I'm typing. So I didn't really end up doing anything, but just to show if you wanted to do stuff, I guess you'd want to move that over so you can see what you're typing. Not a big deal because I didn't have a huge. I pasted random stuff in there by accident. I didn't have a huge desire to do anything in there right now, but anyway, it's good to know, I guess. It could be good for pulling up debug info if you want to like see something in the blockchain without having to write JavaScript out for it and save it. All right, so now the transaction debugger. So we already looked in that a couple of times, but of course when we looked, there wasn't much useful information in there. But it supports both Solidity and assembly level contract code debugging. So this was interesting to me because obviously the assembly level is good to know, but it's not the level at which people are going to be. I mean, if you're using this tool, you're probably not writing, your Ethereum VM commands at the assembly level.
And it's like EVM assembly, right?
Yeah, exactly. It's the
Yeah.
Ethereum virtual machines assembly. Yeah. You see the VM stack, the yellow paper. I printed that out and I've read some of it, but I have to admit I would like to read that more because it goes into some serious detail of what's going on, and so that'd be nice. But basically, it describes how this all should work, and then the people wrote the code in, and you get the call stack, storage, memory, and call data. So all that stuff's in there. And so let me fast forward a little bit to where we actually end up trying that. So then I said, okay, we're at the point now where we want to actually do something. So at this point, to this point, we have, besides the fact that we created a Genesis block and just sent some Ether, we haven't done anything with like a real contract, like with this contract, for example, like that we showed. So to get to the point, just fast forward till we get to the point where we actually do that. Okay, so I started getting a little bit more serious and going, okay, let me. So the example app is like a ratings app, right? It's like, that's just the example. Like it's a way to store ratings in the blockchain. And the way this one's set up, or at least the one from Gavin Wood's page that we've been looking at was set up, is it gives you a key to name what you're rating, which is actually kind of cool. Like you can have like just what's your favorite Ethereum, implementation? Like, oh, I like the C++ Ethereum, or I like, whatever. I like the. So it was nice that it lets you have a key, so you can. What are you rating? Okay, I'm going to give it a name. So I put Star Wars because I was thinking about the movie, and then it lets you put in a value. So I put 11 because what rating is better than 11, I guess. Then I said save. So this is where the rubber just hit the road, right? We really just did something that, at least in this test blockchain, should be a transaction that actually uses a smart contract, saves data in the blockchain. Stuff should happen here, It should be more exciting than the sort of other thing. Right, than just moving the Ether around, right? So let's just, here we can see the from address, the to address, which is kind of cool. It shows you that it was set rating. So if you had a really complicated contract and you're using this thing and you're not, for debugging and everything, you weren't sure, well, which thing would have gotten called? You just see right here, okay, this is where the data got set, was in that method. It's kind of cool. It shows you the gas that was used. So we talked about gas a little bit, but the gas here would be, that would be, Ether that would actually cost you to do that, right? So it's not free to write the data in, and that's what it would cost you. So anyway, but yeah, so it's kind of handy. This thing's still showing as like a pending transaction. So I wanted to click edit to see what I could do with it. And I guess as long as it's still pending, you can just edit it. It shows you the key value in hex, I'm guessing, although I don't know, those are all digits, so whatever. Yeah, so it's going to be Star Wars, and then that's the value 11, and that's the gas. Yeah, so I just left it. I didn't actually update it, but I just want to see what I could do if I wanted to mess with it. So I tried to go on the debugger, but nothing. Well, interestingly, something did happen. So nothing happened when I was here, and then when I went into the VM view, you can see this is the, this is the assembler code or whatever, the opcodes that.
See, and then you see up there, they were right, step cost, total gas spend.
Yep. So yeah, if you're trying to seriously,
It's amazing.
you're trying to seriously optimize your transaction and go through it and be like, can I change the?
Incredible.
Yeah. So all right. So I think the next step is going to be actually mining. Okay. So here we go. I'm going to say, okay, this showing is a pending transaction. Let's actually add the block. So now it just puts block there, but instead of being a pending transaction, it's now in the most recent block. So I expanded it again. Click debug transaction, and I started doing the same thing, but it's probably because what I want to see now is the Solidity level debugging, because I'd seen sites that even let you look at the virtual machine level debugging. Obviously, it's a more complicated thing to look at, but it's not as useful if you're really trying to code at the solidity level. So I want to see, can this thing really debug at the solidity level? So that's what I'm trying. Here we go. So I just need to hide the window that was showing the web view. So there's a thing up there where you can say like hide web view. So I got rid of the window that was covering this guy. And then here's where I'm like, okay, I see the contract there. Let me like give myself some more space and see if I step through the debugger while the contract is showing, can I see stuff happening? So there's not much happening in this contract, so maybe it's just hard to see it stepping through. Because I mean, really, this is the one line that it does anything on, right?
Just sets the value, right? Yeah.
So, but it did. So if you notice, here we go. We'll go back. It does, as I step forward and stuff, it does dynamically update like how much gas is being used or something. And I think it's probably now you see something happening down here. It's overwrite, so it's a little bit wonky.
Yeah, I'm surprised there's no, like every other debugger, it tells you where the execution is, like an arrow.
It's like an arrow.
Yeah, I'm guessing it's trying to highlight it, but because of just like issues, it's like probably trying to highlight it with black or something, and it's not showing. I don't know, like whatever. But it's something, yeah. It's
you can see that gas, like I said, it's
something's happening.
So
And
it has
maybe,
a QT?
So what is the query supposed to do in
so yep. So good question, because here we are. Yeah, so just the right time. So this is where I decided, okay, I gave up in the tutorial a little bit at this point and said, well, the query's got to do something. I don't know if it even mentioned it. I guess they just figure it out. Which I was like, all right. I was trying to go word for word, but
read the stuff?
yeah. So here I'm saying query Star War, and I'm like, there's nothing's happening. Okay, I didn't expect, but then once I actually type the S, I get the 11. So it works. So the query, it's dynamic, right? It's doing the JavaScript trick of every time you do a key up, it does a query.
yeah, and if you look at the JavaScript, it's really transparent. It's literally 3 lines.
Right.
And that query is hitting the
So
blockchain?
that it hits in this case, it's hitting your local copy of the
Local
blockchain.
copy.
So remember, if you're
Right,
running,
but I mean,
it is querying the
Yeah.
blockchain, and that's
That's
free
the
for
whole
you.
thing.
And that only costs you your own compute cycles to look in it.
Yeah.
So remember how there was a part early in the thing where I talked about how it said, do you want to show, I forget what they call it, basically like, do you want to show this info by going to display? It was like tools, I forget what it was. Display calls.
Yeah.
There's that long description of why you might want to do that. And the reason is, if you do that, instead of in the block it just showing what actually happens in the block, it shows the stuff that happened, it shows the queries you made while that block was going on.
Oh, okay.
So at the time of that block, which is, I think, again, it's for a debugging
If
thing.
you're running that on your local node, it doesn't cost the network
Right.
anything. It costs you something, but you're running it locally.
Right. So it's handy because you can see here, I'll just go through, like you see the part where it must have, like this must be Star Wars without the final S. And you can see that it didn't use any gas or anything, but it also didn't get any value out. The next one and the last one that I typed here was, this is Star Wars, right? And then, I guess this is Star Wars in the encoding, and then you get the 11. So anyway,
Why did it take so long?
was that?
Why did it take that long?
So the reason all these happened was every time I typed a letter and the key went up, it did a query. So I mean, you probably, you might not want to actually do this in your,
It's interesting that your query doesn't seem to have taken any gas, though.
Well, because
So it doesn't, because you would be
Yep.
locally running the
Okay.
node that's making that query on your local blockchain. You're not saying, hey,
Okay.
network,
Right.
what's this? You're saying,
Yes.
hey,
Okay.
can you look at the blockchain and tell me
And
what
that's-
this is?
yeah.
You
Yep.
own the node. There's no expense on the network.
Okay.
It's kind of like a type ahead, the one that's doing search call, you must
Yes,
see this.
it was the type ahead, yeah, it was
So,
like the
Put
type
it
ahead
on a
call.
local JSON. They could keep that.
Okay.
Just put it first.
So this is the part, so I tried to look into deployment and I was running out of time, but I was like, well, because I knew this was one of those things that is, a lot of that stuff was really slick and easy. I knew I was like, deployment's not going to be that easy. Just because if it were the case that it was really easy to add tons of data to the blockchain or something, right, it may be easier because all your stuff would just get dumped into smart contracts and you could get it from there. Obviously, in reality, blockchains are still expensive to store data in because everyone in the world that runs it needs it. So in terms of deploying your app, it's like when you deploy it, you don't shove all the HTML into the blockchain, you don't shove all the JavaScript into the blockchain, you don't even shove the whatever they call it, the ABI, the thing that describes how to interface with your contracts in the blockchain. The only things that go in are just the compiled Solidity contract thing and stuff like that. And then of course you need to put your your JavaScript code somewhere and all that stuff. So this is definitely going to be the part where, you know, it's easy to tinker with, but this is going to be harder because now you're actually trying to get it out to the world.
So if you never mind, let's say,
Yeah.
no, I'm not going to
No,
say
yeah,
this
yeah.
to you. All I need to deploy is the location of a real node.
Yeah, so let's just
I
try it right
How
now.
do
So
I
the-
even care? Because if I have a client which is already wired to the network, I don't really should care. Right?
Yeah, you don't need to mine to do any of this. I mean, you'll want to be running Geth, which it's not mining; it's just syncing the
Yeah,
blockchain.
it just
you
gets
don't
it
need to mine
So
now.
when you deploy, it's kind of like sending a transaction and you attach Ether to it, saying, here network, run this thing, and this is your expenses.
Well, that's a good question because I didn't finish the I didn't end up finishing the process.
That's what I'm
So so yeah, it's something like that. You know, it involves getting your it involves getting your contract up there. So let's see what it says. Choose. Can I zoom in? Okay, it doesn't zoom in very well. Okay. Yeah, it won't zoom in. This should only be. It actually looked better on my machine when it wasn't plugged into the HDMI thing. Just for the record. But so yeah, pick a scenario to deploy. So I guess if you're developing multiple scenarios, so that's kind of nice, right? I guess a scenario is sort of like this app involves these contracts and so on, or whatever. So if you want to have various scenarios and you really only want to deploy your go to production one, do that. And you give the URL of your node, which I guess, so I think you could just put an external web address in here, and that way you wouldn't even have to be running a node locally as long as you trusted. Like if you work for a company that develops these things or something, or if you have a friend that has a node, you would be able to just, or if there's an API node out there somewhere, you could just put that info there. Let's see what happens if we deploy scenario. Deployment account, gas price, I guess you can set all this stuff. Deployment cost, deployed contracts, and you can say deploy scenario. So I'm not going to go through all this because I don't know, but let me see. Do I have I think I might have the testnet running right now. Let's see. I think this is the testnet. So we could try to deploy it right now. Let's see. Okay, so yeah, it's running the get testnet RPC fast.
Deployment costs, there we go.
Deployment cost 7.48 Finney. I don't even know, select scenario. Okay, let's just see if we don't do that one. Deploy
How do you
scenario.
wire this to the testnet as opposed to?
So I guess this should try to deploy to the testnet. So this is, it showed that scenario where it says, so this is, the Ethereum node URL. So this is now taking it out of the little sandbox environment that everything's been running in inside Mix, and this is actually going to try and deploy it there. That's part of why I hesitate to deploy it because I'm not even sure. I don't think I have the. Let me just pause this for a second. I don't think it's scenario. So presumably, when I say deploy scenario, it will deploy like the smart contracts compiled bytecode and everything into the blockchain and the smart, and that'll be the smart contract people interact.
So they talk about Ethereum, the Go version versus the C++
Mhm.
version. Is there any, what's the purpose of? From
So
your,
yeah. Right. So the marketing would be this. One difference in implementation of how like Ethereum was approached versus how Bitcoin was approached was Bitcoin was obviously Satoshi Nakamoto wanted to make it work, and so he wrote software in C++ that worked, right? Ethereum had more time and money to like investigate more, and so they wrote more of the protocol first, and then the implementation, which is typically as things get more mature software-wise, that's how it ends up going, right? You think about like all the web protocols and everything. If you were at a web browser now, you'd be conforming to the existing protocol specs. So the idea with Ethereum was they wanted to go more that route. So they wrote out how it should all work more in the white paper, the yellow paper, and whatever. And then people wrote conforming applications. So part of the thing was just to prove that it had more than one implementation, which I guess is nice. So again, instead of having like one core to start from, there are multiple. So maybe that'll be good in the longer term for Ethereum. And so maybe there'll be more like competition versus whatever's going on. You could argue in Bitcoin it could be an issue when.
So they're expecting everybody to have a GPU sitting around just to buy a cookie?
Well, that's only if you want to mine. So I mean, you can get your Ether many other ways, right? So you can, yeah, I mean, if you have Bitcoin, you can talk to one of the guys that sells Bitcoin around here, get Bitcoin, or you can buy it on Coinbase or something. Then you can go to Shapeshift and get your Ether that way. So you only need to mine if you don't want to have to buy real actual dollars or Bitcoin or something. So, yeah.
Quick question on
Yep.
this execution,
Go ahead.
right? So if you talk about execution of this contract
Yeah.
on the blockchain, that means that multiple miners, of course, that's the whole idea is will execute this. So does this gas actually mean it depends on like you expend that much per miner?
No, so good question, but yes, but no. So just in the same way that every miner who's actively mining the block that your transaction is in does work, you only pay the miner that actually won. So it's the same way here. So everybody that's mining or running or whatever, at least everybody that's mining for sure, they have to run everything. Just like in Bitcoin, you got to run through all the transactions or be really tricky or something. But you have to somehow publish your block as valid, and part of that is the other miners will be running all the contracts and getting results as well. And I'm guessing what happens is if they can see you cheated or something, like let's say that you're running through a contract and you realize, oh, this is that contract where I bet $1 million and I really have it not be like I lost that $1 million and you want to do it, your block would, I presume, I hope, be rejected, by the other miner. So everybody would have done the work. Some people may cheat and that sort of thing. But the whole block accepting and rejecting process, I guess, should work that out.
That's transaction validation.
Right. So yeah, it's just like there's more to worry about, I guess, in terms of, but in the end, it's all hashes, I guess, probably by the end. And if the hashes are matching up, people know that's what's going on. That's complicated.
Okay.
So yeah, no. But it's worth I don't even understand all the complications. But basically, there's it's a fluctuation. So the gas is basically Ether, but with a conversion rate, right? I think we talked about this in January. There's a conversion rate, and I think it's even published on the blockchain. And so I'm not going to claim to understand how that's set.
It's like a multiplier. It's like the difficulty value.
Well, yeah, from what I understand, each opcode has a specific gas that it consumes.
Oh, okay.
So when these things are pushed down into that assembly code, there's a specific amount of gas that's mapped to each function. And then the gas and the ether, I've read about 5 times. They're decoupled because something like when the price of ether rises for whatever reason, they don't want the price of the transactions to rise. So that's why they decouple the gas from the actual price of the ether.
So isn't there that thing called Shannon? Shannon is another unit that they use for this?
Yeah, I don't know.
So it's like super derails me over, but it's just like.
Yeah, no.
Yeah.
My feeling was that gas was basically the amount of CPU cycles.
Yes.
And memory.
But gas is how you pay for those.
And I would expect the gas to have a correlation with difficulty required to actually commit those CPU cycles on the VM. That's why I talked about
Right, exactly. That's why I was concerned.
There's probably a difficulty value that dynamically adjusts itself maybe per CPU instruction because they might get cheaper over time.
Right.
Like when they build a CPU instruction into an actual
Right,
chip.
that's what I was worried about. Is like
I wonder
going
if
down
it-
to a lower level of processor. I wanna know
Yesterday,
that's why I would do it.
The opcodes are hard coded as of I listened to the Ether review on so it's a great podcast together.
Oh, okay. Yeah.
The Ether review is awesome. The opcodes are currently hard coded in terms of gas prices, but they discussed maybe we could go dynamically as the market allows.
Okay. Interesting.
Because yesterday, Vitalik posted about setting the price at 20 Shannons or something, and then trying the 15,000 transactions, and he said they all passed. So
This isn't an arbitrary implementation either. There's actually cause of that call for understand it, right?
Right.
You're
Yeah.
fueling the machine and you don't know like really the money required to buy the fuel and how that's derived.
Yeah,
It's a big issue.
Yeah.
this is the one. It says gas prices are down to 20 Shannon. Update your clients to Homestead. Gas price on your miner to accept even cheaper transactions.
I've never even heard of Shannon.
That sounds like Gaba Bob and Baba do.
10 power
Yeah.
minus 8 ether is 1 Shannon, is what I said.
Oh, so it's one of those units like
Yeah,
this.
And from, you know what I mean, yeah. So when I read about it, my shortening summary in my brain is, I don't know where it's at right now, right? If it's just set in the clients or something, but the goal is for it to be some kind of floating thing that's determined by miners or something, sort of the same way that Bitcoin fees should be, you know what I mean?
So there's difference between fees and the difficulty, right?
Right.
Difficulty is also from a consensus based on mining power.
Right. So I don't know, and I don't even know. And of course, with Ethereum, they sometimes have and then different ideas about how to come to distribute consensus using contracts or something. So maybe, what's that? I didn't. I let it keep going because it's actually interesting. No, because it's interesting, and it's one of those things that I still don't.
Okay.
Like I said, these talks, I don't claim to understand everything. So it's one of those things that I'm still
So he
sort of trying to figure out.
gives an example here
Yeah.
of how he set the gas price at 20.
Yeah.
And even though on an average, the gas price of 45 seems to be Shannon's.
Okay.
Seems to be okay. People accept it, so
Okay.
it takes longer.
Okay.
So
Sure.
he said if you are fine with a 2-minute extra confirmation sign,
So it's
it is
like-
way lower. And
It is
not-
related to fees.
Right,
They're,
it's like
they're
a fee,
deciding
yeah.
the fee they're accepting for
I
the amount of
see.
gas they have to expend.
So there you go.
Okay,
That
Yeah.
makes a
makes
ton of
sense.
sense,
That makes
right?
sense, yeah.
And so when they say update your clients, they're talking about the miners, hey, you should change your accepted fees.
Correct, yes.
Right.
That makes sense to me.
So-
Yeah, it does.
Yeah. So that
Hey, we figured it out for myself.
Yeah. There you go.
Yeah.
Exactly. So. Yeah.
Brian, I think you mentioned it last time.
Yep.
So when we actually deploy this Solidity code,
Right.
you can't really reverse engineer that if you're just a miner, right? I mean, let's say I'm just
Right.
doing a block. It's just a hash. It's not like it's that I can kind of look at all the code. You see what I'm
So
saying?
you're
I mean,
probably man of the assembly level code.
Yes,
I'm
so-
guessing, but it's the same as trying to decompile assembly level code.
right. So
Right.
one could build something to decompile because I'm thinking if the banks and all these things, I mean, they would want to have certain level of privacy on what the contract actually is supposed to do, or what is the idea that it should be open?
I think it has to
Well,
be.
it should
Able to turn off the optimizer, so all you see is clean code.
Yes, and you can turn off the optimizer. So this is
But
mixed.
you would never want to do that in
Right.
deployed code because you're
Deployed,
spending more
yeah.
money on inefficient.
Right. And here you go. This is the so that these are options: display gas estimation, enable optimized compilation. So you sort of have those options. Obviously, for developing, you might not want to optimize, just like you might not for developing your C code because you want to be able to debug it more
There's
easily
no
or whatever.
advantage to optimizing on local test that necessarily.
Right. I mean,
Actually testing is close to production.
right. When you're like close to done, you go, okay, do the optimized code. Let me make sure it's. I don't know,
Production
if there's not a bug or something, in the
Yeah.
optimizer. I don't
It's
know.
usually all your test cases in your Genesis block and further blocks and then step through and make sure it's where it needs to be.
Right.
Until it bites you in the ass.
Yeah. Exactly.
Or
And
straight
then
out of
it's saying the
your
responses, contracts, rating, where you're pulling in the ratings per parameters.
Yep.
And that value is at a guide. And then you're linking in the, down there where it says query, see input type, string ID query, and you have on key up, call, get rating. So every time you change something on key up, it's going back up to that get rating call.
running that whole thing, yeah. Okay.
Yep.
Got it. So it's firing that
This
It's
is
firing the
contract's rating
JavaScript.
and it's just looking
Right.
at that.
That's all it is. And
vanilla JavaScript right there.
right. And it's like the
No
met.
query or nothing.
Yeah, no, which is actually kind of nice, right? I like it that in the example, I like it that they took out that complication for this demo because, like I said, if someone getting started, I think it actually is nice. Like honestly, do you need like all of some advanced JavaScript code to be able to just document get element by the? I mean, obviously, when you implement an app that's more complicated, you'll probably use
You
a
can
framework,
boil
you
that
know.
down to about 2 or 3 lines of code. jQuery.
Yeah.
jQuery is pretty much free on the internet now. So.
No, I know, but still, anyway, I like it that it's
Yeah.
reduced internal dependencies for the, so it's not jQuery doing something magical, it's just JavaScript. Anyway, but so this would be where the get rating, this would be where it's actually pulling. So the contracts object is what's linked in probably via Web3 to your actual blockchain.
To the chain,
Instance,
So
yeah.
it pulls it from that. Okay.
This is quite interesting because this means the bar of getting into this is can you run solidity
Yeah,
and HTML.
HTML file in front
But
of
you
it.
mentioned Bitcoin concepts too, so it's.
Oh, right.
That's the big, yeah, that's the interact
But
with.
anytime somebody activates the, your HTML code,
Right.
essentially it's going to burn that ether of gas.
Pay into that contract.
So I guess that comes out of his account.
So I think that you assign a value of gas
Yeah.
to a contract, and that gas goes along with that contract, and then when the gas runs out, the contract's dead, right?
Well, that's a
why
good
you-
question, but I think contracts can, well, at least for messing
One of
with,
their goals is to be self-funding.
yeah, so
Usually-
contracts can accept money, so like,
Oh,
when
sure,
I was-
sure.
yeah, so,
Oh, yeah,
so I
yeah.
think the idea being you'll take a fee, right, or something, and that's probably how people will make money too, right? You'll take a fee to keep the contract running, and then you maybe take a little extra for your, for Papa, and then you can keep using your contract or something, right?
Yeah.
So I think that's part of the idea there.
Yeah, you can use some of the gas just to process.
Yeah. So you put it in some, because once you're in your contract, you can do anything that's legal within Ethereum too, and that's part of what people are talking about. Everybody should publish. Of course, not everybody's going to follow the rules or the good practices or whatever, but I guess the idea being everybody should publish. Obviously, you should publish your ABI. The way that people interact with it, unless you want to be the only one for some reason. I don't know if that makes sense. But you want to publish your contracts interface thing, and then probably you should publish your whole contract source code. If it's one that you want to, let's say it's like a lottery or something, and you're like, look, I want you to use my lottery, and I want you to see the code, and they could compile it and compare the compiled version to what they see in the blockchain and verify. So and that's actually, I think, going to be a business model lottery probably will be a business model too, but also basically if you had a law firm and you were really forward-looking, you could declare yourselves to be like smart contract review experts or something, Esquire. And you could have your website or your Ethereum-based type site up, and you could say, okay, these smart contracts have been reviewed by our team of really smart people we pay a bunch of money to, and we verify that they do what the person selling it, here's the description in words, here's the smart contract, here's the compiled bytecode, here's some hash or something. They do? Okay,
Well, not
cool.
necessarily for Ethereum, but
Yeah.
Cryptographic applications that are open source,
Yeah.
there are third-party experts that will say, this is the hash of the code we were handed, a SHA-1 hash, SHA-6 hash.
Yeah.
And they'll say, we reviewed such and such portions of the code for the following vulnerabilities, these were discovered, they were fixed,
Nice.
etc. You see that in Spider Rogue and a couple other companies that have zero
Cool.
knowledge.